Welcome to the video from Chapter 3 on congruent angles. By the end of this lesson, we should be able to identify and use congruent and vertical angles. Congruent angles are angles that have the same measure, much like congruent measures back from Chapter 2. These are angles that have the same measure. So some notes here. I have angle R is congruent to angle T. And what's important to realize is that this is angle R and is congruent to angle T. These are things. This angle is congruent to this angle. So this angle here is congruent to this angle, which means they have the same measure. This IFF stands for if and only if, which just means that it's a biconditional statement, so we can go forwards and backwards with it. So the angle R is congruent to angle T if the measure of angle R is equal to the measure of angle T. So the difference between this half of the statement and this half is that these are things, these are numbers. Measures are the actual degree values for those angles. So if they're congruent, then their measures are the same. If their measures are the same, then they're congruent. That's what this if and only if biconditional statement means. Vertical angles are two non-adjacent angles formed by a pair of intersecting lines. They're also known as opposite angles. So using this diagram as an example, angle 1 and angle 3 are vertical angles. Angle 2 and angle 4 are vertical angles. So they are non-adjacent, but they're formed by a pair of intersecting lines. So here are my intersecting lines. It has to be 1 and 3 because they're the only ones that are not adjacent to each other, as well as 2 and 4. 2 and 3 would be adjacent, 1 and 2 would be adjacent, so on. They're opposite angles, opposite of each other's vertical angles. We have several theorems in this section. The first theorem is that vertical angles are always congruent, and we're going to prove that theorem using this diagram here. And the first thing that we're going to use is the fact that measure of angle 1 plus measure of angle 2 is equal to 180 degrees. That's the definition of supplementary angles. Then the measure of angle 2 is plus the measure of angle 3 is also equal to 180 degrees, again by the definition of supplementary angles. So because of the transitive property, now we can say that since they both equal 180, then the measure of angle 1 plus 2 must equal the measure of angle 2 plus 3 because they both equal 180, they equal each other. From there, we can subtract the measure of angle 2 from both sides, so a little subtraction property here, a little algebra going on. And so that leaves us with the measure of angle 1 is equal to the measure of angle 3. From substitution, and then we can say that the angle 1 is congruent to the angle 3 by definition of congruent angles. So because this is 180 and this is 180, that really means that 1 and 3 have to be the same. And hopefully you can kind of see that angle 1 is this obtuse angle, angle 3 is that exact same obtuse angle, 2 and 4 are both acute angles in there. But we've talked before, you can't always trust an image, but in this case, you can at least use the image to help see that vertical angles are always congruent. So let's try to use these theorems and properties about congruent and vertical angles to find some missing angle values. We're going to find x and y. When you are given a situation like this, you end up having several options. So I started in green here saying, well, by the angle addition postulate, 130 plus y will equal 180 degrees. They're supplementary, but I'm using that angle addition postulate, solve to get y equals 50 degrees. And we could use that again to find x, but you can also just see here because 130 is opposite of x, they're vertical angles, so x has to equal 130 degrees, and there's no work involved with that. It's just because by that theorem that they're vertical angles, so they are congruent. The trickiest part of these types of problems is really going to be to decide where to start. And there's not always a right or wrong answer. So please just understand that your visual of this this diagram and where your brain is trying to go, or where it wants to go to solve, may not be the same place that mine is going to go, but that doesn't make it wrong. So let's just make sure that we're getting to that same answer and we're using our geometric properties and theorems. So I decided to start with vertical angles here. 2x minus 12 will equal 70 degrees, will equal 70 by that vertical angle there. They are congruent. So I just solved and got x equals 41. And then to find y, in order to find y, we're going to use the fact that they are a linear pair, that angle addition, to say, well, 70 plus y equals 180, so it is 110 degrees. So x equals 41 in order to get this value to be 70, and then y is 110 degrees. Notice that I did put a degree measure on my y value because it does represent a degree, but x is just the value inside that degree, so I'm not putting a degree symbol there. Hopefully we're starting to see over and over again just some repetition with these vertical angles. 4x plus 6 will equal 90 by vertical angles here, and we just solve by subtracting 6 and then dividing by 4. So x equals 21. I'm not finding the measure of the angle because that's clearly going to be 90 by the theorem about vertical angles being congruent. We're more interested in just that value for x. So this is going to be one of those problems where you're going to want to really look at it and decide which variable you're going to solve for first, and based on the information that is given. But I actually want to draw your attention to the fact that in this particular example, we're not able to use the fact that we have a linear pair here first, because then we're mixing our two variables. I have an x in this expression and I have a y in this expression. So we can't we can't add them together and set them equal to 180 degrees, because then we have an equation with two different variables. So there are some limits sometimes when you're solving for multiple variables in one situation. So in order to solve for x, I decided to use vertical angles here. So 2x minus 6 will equal 60. So this is the equation that I set up and solved to get x equals 33. Then because I do know that x equals 33 and I could use that value here now with that linear pair that I mentioned earlier, I'm going to choose not to do that, because just in case I got something wrong. Instead, I'm going to use this linear pair. So I'm not hoping that x is correct over here. I can find y using what's given. 5y minus 10 plus 60 is going to equal this 180 degrees, that linear pair. Solving for y, you get 26. So I was able to solve for y without using x, and I was able to solve for x without using y. And you want to try to do that. It's just safer practice so that you're not getting wrong answers and carrying an incorrect answer through another part of the problem. For this example, we are supposing that angle A is congruent to angle B and that the measure of angle B is 47, but we're supposed to find a measure of an angle that is supplementary to angle A. So starting off first, because they are congruent, we can actually say that the measure of angle A is equal to the measure of angle B, and then we are given that the measure of angle B is 47 degrees. Well, they're equal to each other, so the measure of angle A also must be 47 degrees. Supplementary means that they add to equal 180 degrees. So I'm trying to find some missing angle that adds to 47 to get to 180 degrees. So we can solve for x by subtracting 47 from both sides and getting 133 degrees. So this is the measure of an angle, some missing angle that's supplementary to angle A, and we used a couple different properties here. For congruent angles, that means their measures are the same, substituted in, use definition of supplementary to get to 130 degrees for that missing angle measure. Another theorem from this section is that if you are told that two angles are congruent and supplementary, that automatically makes them right angles, because the only way to add to equal 180 and be the exact same value, they have to each equal 90 degrees. So that's just using some reasoning to get to the fact that that has to be true. If they are congruent and supplementary, then they have to each equal 90 degrees. Last piece for this lesson is theorem 3.7, which says that all right angles are congruent. And again, that's just by the definition of congruency. If they're all right angles equal 90 degrees and they all have equal measures, so then they all must be congruent. So that concludes this lesson for Chapter 3, Angle Relationships. At this point, you have talked about adjacent angles, linear pairs, complementary and supplementary angles, as well as vertical angles, and just the general idea of congruent angles, which we will use again in future chapters. So you want to make sure that you understand what it means to be congruent. They have equal measure. That's going to help us a lot to solve for missing values and missing pieces as we go through the rest of geometry. So thanks for watching.